Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So I've produced videos about this in the past, and some people have asked me to try and make it simpler and clearer. And that is what I'm going to do right now. So let me just shut this window down. Okay. Now, so in geometry, we can perform 100% accurate arithmetic operations, okay, using just ratios of magnitudes. So suppose we have two ratios, red and blue and cyan and green, okay? We could represent the first ratio here with the antecedent part on the y-axis and the consequent part on the x-axis. And there's a good reason I've represented it like that, because I want to be able to show the second ratio, which is the cyan and green ratio, represented the same way, cyan and green, right? So now we have the two ratios. How are we going to find either the difference or the sum? Let's start off with a difference. So let's say we want to subtract this ratio here from this ratio. Well, the very first thing we need to do is we need to find a common consequent. In other words, these two here need to be a common consequent. Yeah? How do we do that? Well, we use similar triangles. So this line here is similar to this line, and this line here is similar to this line. So all we have to do, right, is to position this ratio, or this line, or this line on either one of the end parts of the consequent. So let's say we want to position one of them there, right? So position the holy green one there and that one there, okay, like so. And that tells us that if we want the difference, we'll use these lengths here to find the difference. So it'll be this length minus this length. That's all it is with this consequent. So it'll be this length minus this length with this consequent. All right. So how does that work out? That happens to be 3/4 minus 2/3. Okay. So what is 3/4 minus 2/3? Let's just do a little calculation. You don't have to do this, because all you'd have to do in geometry is just show the ratio, right? This is the result. So this is the ratio. It's the sum is just the addition of these, the concatenation of those two lines. That's the sum, right? And this is the consequent, the common consequent that you see down here. So if we're adding them, so we've got 3/4 plus 2/3, right? So let's do that. So 3/4 plus 2/3. Let's see what that gives us. So that gives us 9 over here plus 8, doesn't it? If I've done my arithmetic properly, that's 17 over 12, which is 1 and 5/12, right? And 1 and 5/12, if that's correct, that will give me the sum wanted. So it would be whatever 5/12 is. Let's just do, because I'm lazy, 5/12. So it's going to be 1.41666 recurring. Okay, so this is a sum. Now, that's the answer that we got there, isn't it? Approximately, because we're only dealing. Let's just make sure these are on the right spot here. And if they are, it's probably this one that's a little bit out of sync. Yeah, there you go. So we see that we performed the measure, which is this ratio here. This ratio here is the sum. Okay, so pen, this ratio, didn't mean to do that. Goodness, hate it when it does that. Okay, so this ratio here is the sum. Okay, very good. Now, the difference would just be this little part here. And I haven't actually implemented the difference because it's very easy. All you do is you take a compass, right? Or a divider, and it's that distance to this consequence. So it'll be that distance to this consequent, right? Okay, now I don't want that, so let's get rid of all that. So that's the difference, right? And as you can see, if we put in the numbers, let's put in the numbers here, show the numbers, then the antecedent is 5 2/3. The antecedent is this line here, okay? I'm sorry, the consequent is 4, and the antecedent, which will be the concatenation of these two lines, is 5 2/3. Right. So if we had to subtract, if we had to do the subtraction instead of the addition, in other words, we want to do a minus there, that would just be 1/12, right? Which would be 0.41666, right? And if we had to actually put in the values here, so if we had to say settings, show the value, and show the value there, okay, then, goodness, I just saw a big blur in front of my eye right now. Oh, that's scary. Right. So if we say 3 minus that, it's going to give us 0.41666. Okay? So I've shown you now how to do sum and difference. I should have shown you difference first, but it doesn't really matter. I showed you both difference and sum. How do you do a quotient? Well, if you wanted to say 3/4, if you wanted to say this ratio, let's hide these numbers again. If you wanted to say this ratio here divided by this ratio, what would the answer be? Well, it would simply be the ratio of this long line to this line. So it would be the ratio 3 to 2 2/3. So it would be the ratio 3 to 2/3, right? So can we check that? How do we check that? It's very easy, isn't it? We'll just take 3/4 and divide it by 2/3. So we'll say 3/4 divided by 2/3, which is essentially the same as, and I'm just taking a shortcut here, it's the same as 3/2, which is 9/8, right? So that's the measure of, that's the quotient. And that would be the result of taking this ratio and dividing it by that ratio and finding the measure. Okay, so essentially you're saying 3 divided by 2/3, which is 9/8, if I've done my arithmetic right. So we said 3/4 divided by 2/3. Yeah, that's 9/8. And 9/8 is just simply scaling the ratio, isn't it? So I'll show you how to do a quotient as well, right? All you have to do, oh, that's just taking the length of this line, writing it down like that, and then putting this consequent in, which is 4. Okay, so actually you don't even have to put the consequent. This here becomes the consequent, I'm sorry. This becomes the antecedent of the quotient, and this becomes the consequent. So it would be 3 to 2 2/3. 3, and I made a mistake here. Let's correct my mistake. It's 3 2/3. So this calculation here was wrong. Let's just clear the board again. I can't see properly, you see. I'm sorry, people. So it's 3 to 2 and 2/3, I think, right? Yeah. So that's essentially the same as saying 3 and 8/3, isn't it? Yeah, now it makes sense. Okay, so if I say 3 divided by 8/3, that's the same as 9/8. Okay, so that would be the quotient. It would be this line here as antecedent, and this line here as consequent. Okay, so now I've shown you the first three operations: difference, sum, and quotient. Now, product involves one extra step besides finding a common consequent and then following through with the rest of the steps. It involves taking the second ratio and flipping these two around. In other words, making this the length of the consequent and the consequent the length of the antecedent. So if this is, that would be 3 and that would be 2. So now, if you wanted to say what is the product of these two ratios, you would take the quotient, which is this line to this line, right? This line to this line, and then you would have the product. As simple as that. So if we show the numbers again, we'd say that 3/4 times 2/3, okay, 3/4 times 2/3, 3/4 times 2/3 should be a half, right? But isn't that what we got? I think that's what we got. Yeah, it would be 3/6, this line here, 3/6. And you could also do it the other way around. You could have flipped this ratio and made this one the first ratio, but then you have to be careful because you'd have to do this in order to get the right result. So the ratio that you flip must always be the second ratio. Okay, well, very well. If you have any questions, post them in the comment section. I'll also give you a link to an article which describes all of this. It's called Theory of Fractions for Dummies. If you're not already a subscriber, become one. Follow me on academia. I'm John Garyville, and this is New Calculus Channel. Till next time.